Hello and welcome to this lecture. In this part, we will start the concept of derivative. So let's first understand what derivative means. Now, if we consider a certain curve in this xy plane, something like this, and we want to find, let's consider a point. Let's consider this point, which is given as x equals to a. At this particular point, I am drawing another point now, which is very close. So this point that I'm considering over here, this point is x equals to a plus h. So as specified earlier, when we mention this value of h in calculus, this h is very, very small. So it is so small that I can consider h as 0.00000, very, very small, and then 1. It is so small that it means that although I've shown so much distance on the curve, it means that this point and this point are very, very close. So let's say that this point x equals to a is x equals to 5. Then a plus h, this point is going to be 5.000 and then 1. Very close. Now I'm going to connect these 2 points together, as you can see in the diagram. So when I'm connecting, I also have to have the y coordinates of these 2 points. So x coordinates we know. Consider that this curve is some y is equal to f of x function. So this point y coordinate will become f of a, and the next one will become f of a plus h. Now what we do is we try to find the slope of this particular uh, chord that we have connected. So this chord, when you find its slope, the slope of this comes out as m is equal to y2 minus y1 by x2 minus x1. So overall the slope is going to be f of a plus h minus f of a divided by a plus h minus a. So this and this gets cancelled, and what we get is this f of a plus h minus f of a by h. Now at this point of time, what happens if I magnify this? You can clearly see that this will be something like a tangent at this point. So this gap, the gap that you can see, I'm just going to shade it. This gap that you can see is so negligible that we can almost approximate this particular part to be a tangent at this point. So the chord that I've drawn, we can approximate it almost to be a tangent at this point, because this part, the red shaded part, is almost negligible because the 2 points are very, very close. So that is why we say that the slope of this tangent at this particular point to this curve will be given by limit h tending to 0 f of a plus h minus f of a by h, this value. So this will be the slope of this tangent. And when this happens, we call this as derivative at this point. So the derivative to the function at this particular point would be given as this. It is also given as f dash of a. That is, derivative at x equals to a to the curve is this. So this particular principle is called first principle. Now using this principle, we are going to solve some problems and find out derivatives of certain function. Now derivative basically is actually rate of change of y with respect to x. That is what we are finding. So if some curve is given, y is equal to x square, we know that y is equal to x square is a parabola. And when I say that I have to derivate it, it means that, let's say that I have to find the derivative y dash at x equals to 1. means that I'll derivate this, I'll get the answer as 2x. This is the derivative, and this basic thing we have seen in the past. So the derivative at x equals to 1 would be 2 into 1, because I'm substituting x equals to 1, you get the answer as 2. So that point is somewhere here, which is 1 comma 1. Now if I draw a tangent at this particular point, that is at x equals to 1, the slope of this is going to be n equals to 2, which we have just found. So basically, by finding the derivative, what we're doing is seeing how y changes with respect to x. That means as x will change, how will y change as a response to it? That is what we are judging, and that's called derivative. So in simple words, we can say that derivative is nothing but rate of change. We'll see more applications of this in class 12. For now, we have to understand that derivative is the rate of change of y with respect to x. And now we're going to apply the first principle, the application of first principle in some problems. So let's get started. Let's start with some simple problems. So this time the function is given as 4x plus 5, and we have to find f dash of 3. So obviously, according to the basic principle, the first principle, we know that f dash x is limit h tending to 0 f of x plus h minus f of x divided by h. This is what the first principle states. So f of x plus h, in this case x is 3, so f dash 3 we can write as limit h tending to 0 f of 3 plus h minus f of 3 divided by h. So f of 3 plus h according to this is going to be 4 times 3 plus h plus 5 minus 4 times 3 plus 5. So finally when we substitute this and simplify, what we are going to left out with is 12 plus 4h plus 5 minus 12 minus 5. So 12 and minus 12 goes, 5 and minus 5 goes. What we get is this. H and h will go, and ultimately what we are left out with is 4. So that is the derivative of the function at x equals to 3. Let's take some more examples. This time we have the function y as 1 by x, and we have to find the derivative of this using first principle. So f dash of x is going to be limit h tending to 0 f of x plus h minus f of x by h. So this is going to be written as 1 by x plus h minus 1 by x by h limit h tending to 0. Now when we simplify this, we are going to get minus x minus h divided by x into x plus h into h. So you can clearly see that this and this will go. What will remain is minus h. So minus h and this will get cancelled with a minus 1. Now we have an expression like limit h tending to 0 minus 1 by x into x plus h. Put h as 0, then we get the final answer, that is minus 1 by x square. So given a certain function, at any cost, we can find the derivative of that function using first principle. Let's get deeper into this now. Let's take better examples. This time, we are going to have the function as f of x as x minus 1 into x minus 2. Now we know the usual method of derivatives, that is, let's open this up, x squared minus 3x plus 2. This is the actual function. So if I find the derivative by normal method, we're going to get it as 2x minus 3. This should be the answer to this question. But let us prove it through the first principle. So f dash x will be limit h tending to 0, f of x plus h. So wherever x is there I'm going to replace by x plus h. So x plus h the whole square minus 3 times x plus h plus 2 minus x square minus 3x plus 2 divided by h. So you can clearly see that now we will have x plus h the whole square, which you can open up as x square plus 2h plus h square minus 3x minus 3h plus 2 minus x square plus 3x minus 2 divided by h. That's what we have. Let's move further and see what we can get out of it. So you can, one thing for sure, which you can see is that x square and x square will get cancelled. Here we have plus 3x and here we have minus 3x, so that will get cancelled. And plus 2 and minus 2 also will get cancelled. So what we are left out with is 2h minus 3h, which is going to be minus h plus h square divided by h. So you can clearly see that h comes out and h minus 1 remains inside. And this is going to be h. So this h and h will go, and we get the derivative There is one mistake, however, in this expression. The middle term over here should be 2hx. So overall, 2hx is there and this minus 3h remains. So let's correct this expression. What you get is 2hx plus h square minus 3h divided by h. Limit h tending to 0. So now since h is common, it gets cancelled in the numerator and denominator. And what we are left out is with 2x plus h minus 3. Now when we substitute h is 0 over here, all that we get is 2x minus 3. Now 2x minus 3 is what we are supposed to get originally. This is the derivative of that function. Let's take some more functions now for evaluation. So this time the function is going to be x plus 1 by x minus 1. We will find the derivative of this function using first principle. So of course f of x plus h from here is going to be x plus h minus 1 by x plus h minus 1 plus 1 by minus 1, of course. So limit h tending to 0, x plus h plus 1 by x plus h minus 1 minus x plus 1 by x minus 1 divided by h. That's what we get. So further, x plus h minus plus 1 into x minus 1 minus x plus 1 into x plus h minus 1 divided by h into x plus h minus 1 into x minus 1. That's what we get. So here we have to apply the limit now, that is h tending to 0. Let's see on expansion what we get. So expand this. On expansion, we're going to get x squared plus hx plus x. Next, we're going to get minus x minus h minus 1. As far as this is concerned, we will get minus x squared plus hx minus x plus x plus h minus 1 divided by h into x plus h minus 1 into x minus 1. So you can clearly see that this x square and x square will get cancelled. The hx part also will be cancelled. The x part, however, will be added because this minus and minus will become plus and you get 2x. Also, this minus x and this minus x will be added and become minus 2x. So again, they will cancel out. And then finally, what we have is this, that is minus h, and this will be minus h. So minus h, minus 2h is what we get, and over here this will be minus 1 plus 1. That will be 0. So on top we get only this, and at the bottom we'll have x plus h minus 1 into x minus 1. So h and h goes basically, and what we get is minus 2 by, if you put h as 0, because you know that limit h is tending to 0, put h as 0 and we'll get 2 by x minus 1 the whole square. That is the answer to this question.